So let's finish up here 6.3 with example 6 here, using some of those formulas that we just talked about. These are identical, right? This is 4n, 4n, 5 and 5. 1's minus, 1's plus, so we can use that sum difference formula that I talked about. You can take the whole first item and square it, and I can take the whole second item and square it and put a subtraction sign in between them. 4n squared, so I take that through to both. That gives me a 16n squared, and 5 squared is 25. Just like that, I'm done. With this item, this is the equivalent of the square of a binomial. So according to that formula, which is just move this up here, this is the formula that we had. So my a in this problem is 9y, so I put a 9y there. And I put a 9y there. My b in this problem is an x squared, so I put an x squared there and there. So I have 9y squared, I put the 9y in for a, I put the x squared in for b, and an x squared in for b. So I have to take that and square that through, so that is, that means it gives me an 81, because 9 squared is 81, and y squared is y squared, right? Y squared is y squared there. Negative 2 times 9 is negative 18, I have the x squared and I have a y, and x squared squared is x to the fourth. Continuing on here, this is now cubed, so I'm using the cube of a binomial formula, which is that right there. So the problem is obviously us remembering this and plugging everything in. So this whole first item was a, so that means that went in there, the whole first item went in there, the whole first item went in there. The last item is b, which is 2, so I put a 2 there, put a 2 there, and that is 2 cubed there at the end. So I have to take that cube through to both, so that's a cubed, b cubed. This is a squared, b squared, and 2 times 3 is 6. And we have 2 squared is 4, 4 times 3 is 12, and an ab, and 2 cubed is 8. So there's your answer there. If you remember the formulas, it really is a great time saver, but if you don't remember the formulas at all, you can still just FOIL to get the answer. Keep that in mind. From 1982 through 1995, the number of softbound books in millions sold in the U.S. and the average price per P in dollars can be modeled by this. So we have N and P. T is the number of years since 1982, so we want you to write a model for the total revenue received for the sales of the softbound books. What was the total revenue from softbound books in 1990? Well, we need to set up an equation. Revenue, when you're trying to find the revenue, basically you're going to take the number of books times the price. So it's basically this times this. So what I'm saying is I have to basically FOIL this times this, plus this times this, plus this times this, plus this times this. It's all foiling. So when I FOIL all of that and I combine my like terms, this is what I end up getting. So T, I said, stands for the number of years since 1982. And it says, what was the total revenue from softbound books in 1990? Well, from 1990 to 1982 was 8 years. So I put an 8 in everywhere where there was a T, and I plugged it in, and we ended up with roughly $7.02 billion. So this was just there as a formula to show you that you can distribute even with decimals. So take a look back through this and make sure that you distributed everything correctly with the decimals, because these are the answers that I got. And there's your homework. So if you have any other further questions or concerns, please feel free to email me at any time.